Hello friends, we are in the second session of using the harmonics of zero sequence components for detecting of the ground fault in a sensitive manner. In the previous session, in the first session, we discussed about how the block of this operation starts, which parameters are required to be past the thresholds so that it starts the operation. In this session, we are going to discuss more about inside of this operation which components are required that the direction characteristic should work, and also the angle between the voltage and the current, means zero sequence voltage and zero sequence current, the angle between them, how they are calculated, and what these bypass filters do in our block diagram. Here at the first, after starting of this operation, after it starts the operation, this block starts the operation, we require three signals. One is forward and forward plus or minus section, that's delta phi, which should be supplied for the direction, determining the direction characteristic, and another two signals from the harmonics of zero sequence current and the harmonics of zero sequence voltage. These harmonics of these components, harmonics of zero sequence current and zero sequence voltage, they are initially themselves, zero sequence voltage and zero sequence current, the instantaneous values, are sampled at 1 kilohertz, and that sampled is supplied, that sampled values are supplied to bypass filters. Whenever we select this, we select which harmonic should be selected for using for utilization, the fifth harmonic or third harmonic. In this example, for example, we select the third harmonic to be used for determining the direction and the sensitive fault. So these two bandpass filters, they only pass the third harmonics of our sampled values. They pass the third harmonics of the zero sequence current and zero sequence voltage, which are sampled before, and they are sampling continuously. And now the zero sequence current, the third harmonic of zero sequence current, is supplied to this threshold block. When it goes beyond the threshold, how much it should be, these thresholds we will discuss later on. But let's consider that when it passed the threshold, then the output of this threshold block is supplied in three ways. One is going for a start, another is going for the holding the direction result, and the main one goes for the direction characteristic block inside of this operational block. And before, important point is that before the threshold, just after passing the filter, after this bypass bandpass filter, the signal is going for the angle calculation. Now, this signal first is supplied for the AND gate for start, and the main one goes for the direction characteristics, another goes for the holding the direction result, and one is going for the angle determination just before passing the minimum threshold. It means we do not need threshold just if we select which harmonic should be selected in our setting. Whenever this is sampled, this is just going for the angle calculation between voltage and current, zero sequence voltage and zero sequence current. And here for the voltage, the instantaneous values of zero sequence voltage, which is sampled at 1 kilohertz, this is going by bandpass filter, and that bandpass filter only allows the third harmonic. So this third harmonic is the going to this threshold block, And just only before going to threshold, this one goes for the angle calculation immediately without passing this threshold value. This threshold value of zero sequence voltage, whenever when we select the third harmonic, now third harmonic is passed, this third harmonic, if that third harmonic of zero sequence voltage be greater than the 0.02% of V rated of VTs, voltage transformers, when it goes higher than 0.02% of V rated, then it passes and goes for this direction mode, which we select should be directional or non-directional. So if it is non-directional, so it we do not need voltage to be supplied in these characteristics, so it is going nowhere. And when we select the directional mode, then the signal is going to be supplied to directional characteristic for determining direction. Yes, it's going. That switch is on. Now the signal is passed. Another directional and non-directional also goes for the holding. If we select non-directional, so on non-directional, our signal will not be holded. Why we hold it, we'll discuss it later on. And when it is directional, so from the zero sequence current, the third harmonic of zero sequence current, the third harmonic of zero sequence voltage, now the AND gate is on, it goes for the directional result extension. So this is used when this zero sequence voltage and zero sequence current, that harmonics of these two guys, when it is supplied, so sometimes it may be now disappear, one of them, it will be disrupted. So this signal for the directional result signal should be holded for a few times so that it should hold this directional information. Here, just it goes for angle calculation and this angle calculation now, and gate is fulfilled. Now the result should be extended for a few milliseconds. The direction result, it should be holded. It is going to the direction information block. In next session, we will discuss why we need this directional result extension in more details, and about the stabilization counter, and about the peak subs, the remaining blocks and the thresholds remaining, how much should be these threshold values, and how really the graph and the phasors are used inside of this block so that it can determine the direction. We will discuss in the next session. Please subscribe our channel and help us provide you free educational videos, training, practical, and these clips, such clips and such topics are not available in the YouTube or in Google. It's a little deeper knowledge beyond the operational of the relays, and it's just operation of relays inside, how they operate, and it's required for the control and protection engineer to know the inside of operation of each function, so that that engineer can decide which one of these methods should be used for sensitive ground fault detection, and also for the troubleshooting. Sometimes our system operates not according to what we want, so we can determine that, okay, why this function works. For example, we select the fifth method using harmonics. In the harmonics, if we select that harmonics, and we know that here the zero sequence components are neutralized, they are filtered by the zigzag transformer. Zigzag transformer is used in our system. Now, if we select this method, if we select the fifth method, so it will not work because we don't have any component of zero sequence components in our CTs and VTs, because during the fault it is just filtered by the zigzag transformer. So definitely our discussion is really helpful for the protection and control engineers to know, and it is also useful for the for some guys that they want to do some research. It's fully recommended for the postgraduate students and master students to have a view and watch our clips, our training, so that they can decide in which field there is a drawback. We will mention later on which portion, which methods have a drawbacks and what are those drawbacks, how to overcome them. Those are the mainly topics that a researcher can research and to decide as a topic for research. Please help us provide you more free educational training videos, and subscribe our channel. Do not forget to mention your friends. Comment in the comment sections if you have any queries related to the topics. Good luck.